recapping what we did yesterday. Yesterday, we talked about, we're analyzing Thomas's measurements of the snowfall, right? From noon to midnight. Agree? All right. Last thing we found out was what was the average rate of change from 1 p.m. to 6 p.m. We're all good? Yeah? Okay, next. So continuing with 7. So on 7, it says, what was the average rate of change of the height of the snow between noon and midnight? So at your table, please find the average rate of change from when it wasn't snowing to when it started snowing. Ready, set, go. So for here, the first thing you should have did was determine your beginning and your end, right? How appropriate is this song for this? You just said oh my god, I did not. It just all came together. So from noon to midnight, right? So that means I need to find f of 12 and I need to find f of 0. What was f of 12? 0.5, and f of 0 was 0. So to find my average rate of change, that's going to equal the change in my y over the change in my x, correct? Change means I'm subtracting. So we have a half minus 0 over 12 minus 0. That's going to give me 0.5 over 12, which is approximately 0.041 inches per hour. Make sense? Okay, so overall, even though it stopped snowing, if the rate was supposed to be consistent, if it was the average rate of change consistently, then it would be dropping snow 0.04 of an inch every hour. That's how long it would take for us to get to the maximum amount of snow we had from over that 12-hour span. All right. Next, what does it mean if a function is generally increasing or decreasing? And what this is asking is in terms of average rate of change, how do I know if a function is increasing or decreasing? In terms of average rate of change. Like if all I know is the average rate of change, how do I know if the function is increasing or decreasing? There we go. So we know that it's increasing if A rock is positive. Where's my pen? Got it. I found it. It was hiding. So we are increasing if A rock is positive, and we are decreasing if A rock is negative. Okay. How do we feel? Still good with interpreting graphs? Using that math and common sense together? Bam. Life skills happening here. All right. We're going to switch gears. Flip. Okay. On the back. So yesterday I wanted you to describe anchor people, right? Anchormen, like what the weather is doing. Today you are now headline writers for an online article. Okay. The graph shows the number of people who watched the Super Bowl on TV from 1990 to 2019. Okay. Your task is to create a headline for an online news article about the data set shown in the graph using a specific interval and the rate of change for that interval. I'm going to assign you your intervals per table, okay? You're going to find your average rate of change and then create a headline based on your average rate of change, okay? So I'm going to model it first. So we're going to do Miss Jones's first. So I'm going to assign myself 1990. So I'm analyzing from 1990 to 1995. Okay, so from 1990 to 1995, I'm going to look at my data. Well, in 1990, it was at 73.9. In 1995, it looks like it's at 83. 83.9. Well, okay. No, because you're going to write your own down. I'm modeling for you right now. So 1990 was 73.9. I'm going to make, this is going to be 83.9. So then now to find the average rate of change of my given interval, that's 83.9 minus 73.9 divided by 5. Why? Because that's a 5-year gap. Is that cool? So that's going to give me 10 divided by 5, which equals 2, right? So 2 million increase per year, right? That's my data. So now I got to come up with a headline. So my headline is going to say, let's see. It's even though we had a fall in viewership, we're still on the positive. Does that make sense? Fall, that's how you spell fall. Fall in viewership, right? Fall in views, but we're still positive. Does that make sense? Because for mine, even though when I look at the graph, we're increasing, and then what happened in 1995? There's a drastic fall. But overall, based on my average rate of change, it is still a positive incline. Yes? All right, so here we go. Are y'all ready to be giving your intervals? All right, you guys are going to be 1995 to 2000. You guys are going to be 2010 to 2015. Girl, 2010 to 2015. Caleb, you want to join this table? Right here in the middle. And you guys will be 2000 to 2010. You two, you're going to be 2015 to 2014 to 2019. Y'all are going to be 2000 to 2005. And then last but not least, let's give you 2005 and 2015. All right, so find your average rate of change for your given intervals and come up with your headlines. You got this. I'm going to give you 5 to 6 minutes. Be creative. Okay, so our story or headline depended on our interval. Okay, if I'm on a positive or short interval, so whether it's positive or negative, depends where we are. Okay, that's the biggest takeaway there. So when people are like, oh, politicians are giving you wrong data, it just depends on where they're looking at, right? Or those facts aren't correct. It depends on where they're looking at. Okay. All right. Next, overall, what was the average rate of change for the Super Bowl viewership from 1990 to 2019? And do you think this is a good representation of the change in viewership over the 29 years? Okay. Yes. Oh, I just paraphrase. Whether it's positive or negative depends on the interval. Yeah. Okay. All right. So at your tables, find my overall viewership. So they gave us our values that we're using, right? For 1990 and 2019. So using those values, here we go. So when you did this, so to find your average rate of change. Right now we're pros at it, right? Over a 29-year window, and we should have gotten roughly 0.84, right? In terms of this problem, what this means is that 840,000 840,000 viewers per year. Does that make sense for this? Was it over the whole span? I'm looking here. It would if we didn't have what? This right here, right? After Tom Brady lied to us all, what happened to viewership? It actually went down. So this would have been a probably pretty good accurate estimate of increase per year. However, we have this huge decline right here, right? So is this a good estimation? No, it's probably not a great representation. And that's just because of the decrease from 2014 to 2019. And notice that this was prior to COVID. So people were like, oh, you know, football changed after COVID. No, people stopped watching before COVID, right? This was way before. Okay.
They take streaming numbers into account.
They take all yeah.
Meanwhile, the World Cup goes.
Yes, World Cup keeps going. All right. Okay. All right. Yes, we're good. Next part is analyzing where is our year of the greatest growth, positive, and how would I choose that? We're just looking for 1 year, like from.
I said 92 to look at that.
Because what are we analyzing for the greatest increase? We're looking for the what? The steepest, right? We're looking for the steepest change, right? So if we're looking for a positive, we're looking for the steepest line, right? So positive is going to be the steepest increase. And our steepest increase appears to be from, I would say 92 to 93. And I can always test it out by actually doing the math, right? Or approximating. It's about a 10-year change in 1 year. I don't see anything that's more than 10 years. So we're say from 1992 to 1993. That's a weird 3. All right. Over what year was our negative? So we're looking for a negative but steep.
2017 to 2018.
Our steepest decrease. Okay, we got what year?
2017 to 2018.
Yeah, oh yeah, that's pretty steep, right? Yeah, 2017 to 2018.
That's because 2018 was right?
I don't know. I just know that what year this was. All right. Is that easy enough to analyze? And then could I back it up with the math? Yes, I could back it up with the math and show that there was about a 10 million viewer increase from 1992 to 1993. And then there was about a 8 million viewer decrease from those 2 years. Okay. How do we feel?
I feel like $1 million.
Okay. And then over here, what is the biggest overall growth? What was our biggest growth from where to where?
2005 to 2015.
Just 5-year interval.
2005, 2010.
There we go. Good job. Look at y'all analyzing data. That's going to be our greatest positive, right? All right. Well, let's be our biggest 5-year gap in negative.
15,
Well, we don't have 20 data, so we can't put 20.
2014 to
2014. Well, that throws us off, right? That spike. I think it's going to be like this up and down heavel here. This ink from 2000 to 2005. This up and down situation here is going to probably be our lows. And that's going to be because overall it's going to be a decrease, which means that it's going to have a negative rate of change. So this was a decrease by 2 million, and this one was an increase by 20. All right. We weren't able to do our think, pair, share, and our exit ticket. So those think, pair, share, we did a lot of talking about our groups today. Good job. Your exit ticket is now your homework. It's just 4 questions. You can get it. It'll tell you if you're right or wrong. You get 3 attempts to check and make sure that you understand the concept of average rate of change. Today is our last day of average rate of change. Good job.